Now, Scott Lee is a local resident here in Melbourne, has actually studied law at the University of Melbourne and has an entrepreneurial fellowship at the University of Melbourne. He has been involved in the startup of a number of web enterprises and has been involved in the Bitcoin environment for quite some time. Today he's going to talk about what opportunities there are of working with the protocol and making it more accessible. So please join me in welcoming Scott Lee.
Okay, so before I get started, I just want to get a sense of you guys and what you know about Bitcoin. So raise your hand if you own some Bitcoins. Okay, that's most people. So keep your hand raised if you are a developer. All right, we've got three, nice. So I'm going to try to keep this talk as non-technical as possible. And the focus of it is, as you can see, Bitcoin as a protocol. And this is really in contrast with Bitcoin as a currency, which I actually don't think is very interesting. I mean, we certainly don't need another currency unless it yields some substantial benefits in its applications and use cases. So why is this protocol stuff important? You know, isn't this just nerdy IT stuff that I don't need to know? Like, most people just ask me about Bitcoin just to, how to get rich quick, essentially. But let me paint a picture for you. A new technology has just emerged, seemingly out of nowhere, but is actually the result of 2 decades of intense research and development by anonymous researchers. Libertarians project their visions of freedom and revolution upon it. Technologists, nerds, are transfixed by it. And meanwhile, the mainstream still doesn't quite get it and can't see what you use it for. Any ideas what I'm talking about? Any guesses? Yes, it is the internet in 1994. So back then, to truly understand the opportunities and exploit them, the early innovators really had to understand the internet at a low level before they can build the layers of abstraction like browsers, Netscape, these days Chrome, and companies above it. Under the hood, the internet runs on TCP/IP, and you could say that Bitcoin is the TCP/IP of money. And to truly understand what we can build on top of Bitcoin, we really have to know what the protocol actually is. And the protocol offers us a number of ways that can help us solve these problems in payments and finance. And it's my personal belief that most of the innovation and value that we're going to get out of Bitcoin is really going to come from the ground up. But before I get into that, I'd like to just share a little bit about my personal history, and that should illustrate how I came about these perspectives. So previously, I studied a Bachelor of Law, but the prospect of becoming a lawyer was very unappealing. The world doesn't really need more lawyers. So I knew how to code and got into Bitcoin late last year. And since then, I've built a number of open source projects in Bitcoin. And so I'd like to show you some of the more notable ones. Okay, so the first one is TipperCoin, which is a service that lets you send Bitcoins over Twitter. But okay, so I'm going to need a volunteer. So raise your hand if you have a Twitter account and want some free Bitcoins. Okay, you, sir. I think you were first. Okay, so, you know what, we thought it'd be cool if you could just go on Twitter and say something like, so what's your Twitter handle? Crypto FIEN. So the one over here? We thought it'd be cool if you could just go, hey, great job. Have 0.001. Sorry, it's not that many. BTC. We thought it'd be great if you just tweet something like that, and thank you. And it will just send some Bitcoins to you, and that's exactly what it does. All you have to do is hashtag tip a coin. All right, so what this does is I've linked my Twitter account with this particular, with tip a coin, and deposit some money. It acts as a wallet. And when I hit tweet, our service listens to all the hashtags with the hashtag tip a coin, and processes that transaction to the recipient here, CryptoFiend. And you will get a notification very shortly saying that I have sent you this amount in Bitcoins, and to claim it, you need to authenticate your Twitter account. We ask for pretty much no information. And then it sets up a wallet, an address for you, and you can spend that money, withdraw it, or tip other people. And it's just a layer of abstraction. Go on.
What's the biggest tip you've seen?
Okay, I'm not sure the biggest tip, but the biggest person tip is Andrei Anopoulos, who is the chief security officer of Blockchain Info. He's had hundreds. Also, people have also tipped William Shatner just to get him to, get on board. So one of the cool things you can do with this is instead of tipping BTC, which is, you got to put 0.0001, we allow people to just have relaxed syntax. You can put in one beer, and that is essentially $4 of the current BTC USD price of, say, Bitstamp, or one coffee. But we also added one Shatner, which is 0.001701 BTC, because that number was the number of his Starship. So it was really just a layer of abstraction to help people kind of adopt Bitcoin. Addresses are really ugly. You just want a name. That's how things should work. And another project I made is Spare Coins, which is similar to CryptoKit. It's a Chrome extension wallet inside your browser. All of this is open source, so you can check it out and play with if you want. And the basic idea is this. Let's say you're on a site here and you want to make a donation. You got to copy this link, you got to open a different browser, you got to sign in, password, blah, blah, blah. Spare Coins, run in your browser, copy paste, and paste it in a Chrome extension in your browser, and then specify how much you want. In this case, 0.01001 BTC and send. So that'll go through, and that's just been sent. And it's just a very easy way to kind of deal with Bitcoin. Now, lastly, I'd like to show you kind of a novel project I made. One of the interesting features of Bitcoin is that you can actually embed data into the blockchain, arbitrary data. So for Valentine's Day, we thought it'd be great if you could embed love messages into the blockchain, because roses will wither, but the blockchain is forever. So you can see people have written some great messages here. Some boring ones like Happy Valentine's Day. But the list goes on. It's got some pretty great use. But through building these projects I've mentioned, and as well as a lot of other ones I haven't mentioned, it just became very apparent that the developer infrastructure is just a raw, complicated mess. And it's really hard to build these tools that, even do very simple things. The tooling just isn't there. An analogy is, it's kind of like trying to build Spotify using iTunes as a backend. iTunes works great, but you can't use it to make a massively scalable service. So that's why we decided to focus all our attention on HelloBlock.io, which is, not as sexy or interesting, but it's certainly, I think, more important. And it's a developer platform that hosts Bitcoin infrastructure for you, so you can really focus on creating Bitcoin apps and consumer products rather than having to think about all the unique quirks in the protocol. So it's currently open source. Well, most of the code is open source. It's in beta. If any of you guys are building Bitcoin apps, I'd love to talk to you after and see if I can help in any sort of way. By the way, it's free. So if anyone, so come talk to me afterwards. I want to ask you guys a question. What do you think is the benefit of Bitcoin? And this is a trouble, something I had trouble answering for a very long time. Yes?
Zero trust, consensus proof.
But what's the benefit of that? Okay, reliability. Yep. Anything else? Any other? Why do we even need Bitcoin? What's the point? Human economic freedom, reliability, that's great. What else? Directness. Cheaper, maybe? Fees? All right, so fees is actually the one that a lot of people tend to preach, and something I have a lot of trouble with, because the fees argument for Bitcoin is not going to hold. And this is because of a number of factors. So right now, the Bitcoin network can handle 7 transactions a second. And this is nowhere near the amount that Visa can handle, which is 10,000 transactions a second. These are for various reasons, such as blockchain size, scalability, et cetera, et cetera. And the second reason, factor is mining revenue right now at 25 Bitcoins a block is going to halve to 12.5 Bitcoins a block. So we've got kind of a floating fee here that's going to be ultimately determined by miners. And let's imagine in 5 years, this 7 transactions a second limit isn't going to cut it. We've got 50 transactions a second. Miners aren't getting paid enough. Obviously, what they're going to do is only accept transactions with high fees. So I don't think it's actually unreasonable to think fees for transactions are going to go up to $1 or more. There are other kind of solutions people are working about, but certainly being, a couple of percentage points cheaper isn't very interesting. I don't think Bitcoin is certainly, just a cheaper way of doing things. It actually offers entirely new possibilities of what you can do with money. In 2010, Satoshi Nakamoto said, Bitcoin supports a tremendous variety of transaction types that I designed years ago. Escrow transactions, bonded contracts, third-party arbitration, multi-party signature, etc. If Bitcoin catches on in a big way, these things we'll want to explore in the future, but they all have to be designed at the beginning to make sure they will be possible later. One can argue that Bitcoin has caught on in a big way, and this is now the time to explore these things. What we're talking about is smart contracts. But before I go into detail, let me just set this up with an example. Vending machines. This is perhaps the primitive ancestor of all smart contracts. The machine takes deposits, coins, and dispenses a product. Anyone can participate, if they have coins, with the vending machine. And importantly, the contractual clauses and the 5 elements of what makes a contract are all embedded within the machine. Let's go through them. So the machine offers products and tells you how much they are. You accept by putting $1 in. The consideration is the value of the dollar. Intention and certainty are obviously met. The machine also handles enforceability by limiting the amount of potential locks. The lockbox and other security mechanisms make sure that the contents are safe as well as the stored coins of the vending machine. And this means that the vending machine can be deployed profitably at a massive scale. But let's just go back to Bitcoin. Now, in a traditional financial system, a transaction is simply a transfer of value between party A and party B. All the logic around it, the contractual clauses, are on paper, are in documents. Whereas in Bitcoin, a transaction is actually an executable script. You don't need to understand what that is. No one does. You have programs to parse it, but all the logic is actually contained in that script. And there's actually an entire scripting language built around this that offers all sorts of possibilities. So here are some examples. Let's consider a basic escrow example. So let's say you're an expert on internet auctions of antique cars. Previously, the buyer would need to send the funds to the mediator. The mediator makes a judgment and releases the funds to the seller. You, of course, trust the mediator's ability to judge whether an antique car is in good condition, whether the seller is selling what she says is selling. But the problem is you also need to trust that the mediator is not going to lose your funds, that they're not necessarily malicious, that they have good internet security, and that they're going to protect your funds in a secure place. This is a problem because it makes it difficult to become a mediator. The Bitcoin protocol, however, allows for multi-party, multi-signature transactions whereby the seller and the buyer can communicate directly. And the protocol would require that the transaction is only released if the third party, the mediator, provides his or her signature to the transaction. It's important to note that the money never touches the hands of the mediator, and the two transacting parties don't actually need to trust the mediator to secure the funds. So this way, the contractual clauses are kept within the transaction without the risk nor the need for trust. And this means the mediator can't steal money, and it's easy to become a mediator, and it can really enable new markets, and because it's massively scalable. But we can take this one step further and make this more like a vending machine. What if the mediator is actually a program, a computer? Let's call this program an oracle who provides its signature, its release clause, based off whether a condition is true or false. So here's an example. Consider an old man who wants to give his inheritance to his daughter either when her 18th birthday is met or when the man dies. The first condition is actually very easy and impossible today. There's a feature called lock time whereby in every transaction you can specify a time when these transactions can be reused. And that's something that all the miners, all the Bitcoin protocol nodes agree upon. The second condition is a little bit harder to meet because the Bitcoin protocol and miners don't really have a concept of life and death. So we're going to need some sort of external state to validate this. What the old man can do is give his son money conditionally based on what an oracle says. And the program could every day check online death records to see if there's an identity match between the old man and the database. And in states like Missouri in the United States, these kind of records are online. They provide an API, an easy access point to get this data. So the old man could also require multiple mediators, multiple oracles, just in case one of them fails. And suddenly, you just cut out lawyer fees because you no longer need them to draft a will. All the contractual clauses are kept inside the transaction and ultimately in the blockchain and executed within there. So this is one example, but you could actually do this for anything. You could do it for betting. Who's going to win the next FIFA World Cup? You could do this for derivatives, futures, and options. Is the price of Bitstamp going to reach $500 in a week? And now you have an authoritative source to validate all this, and you don't have the human transaction costs. Now, another possibility is assurance contracts. So this is when an entrepreneur would say, if enough people pledge me money and I hit the target of $100,000, I will build X. And X might be, I don't know, like a robot that cleans toilets or something. This might sound very familiar to you. This is Kickstarter, and it's been brought to the public attention via Kickstarter. But there are two problems here. The first problem is our traditional financial system can't handle small amounts of money very easily. I'm talking about micropayments. For example, if you just want to get a website translated, let's say you're visiting a Chinese site, and enough English people are visiting a Chinese site that you need, there is value in someone translating it. It's hard to kind of make these things happen. The second problem is Kickstarter needs to hold and move funds, and this is what makes it expensive in this entire process. What the Bitcoin protocol offers is a direct way for people to create what's called an insurance contract. Anyone can become essentially an input in the transaction. And so the benefit of this is that money goes directly from the pledges to the entrepreneur, never touches the hands of Kickstarter, which makes it not only cheaper, but it would also work actually a great tool for them because Kickstarter could then focus on what they're good at, which is a good front-end user experience and marketing, and let Bitcoin handle the entire back end of this financial transaction. And this would ultimately make it easier and, so not only easier, but cheaper for consumers at the end of the day. Lastly, I'd like to talk about smart property. So it's important to understand that arbitrary data can be attached to the blockchain. And this opens up infinite possibilities of what you can do. For example, a company might want to issue shares and maintain the share registry, the transfer of ownership, all inside the blockchain because it's an authoritative distributed ledger book. But what you can also do is facilitate voting rights and perhaps even pay dividends through the blockchain. Now, this is kind of all, 5-10 years out. You're not going to be able to do this in 1 or 2 years. And this goes back to the concept that Bitcoin is just a protocol. There are numerous opportunities to build other protocols on top of the Bitcoin protocol that can enable this. Maybe there's an altcoin for IPOs, for share, company management, et cetera, et cetera. I'd like to now just conclude and sum up a couple of points about smart contracts. So the cost of doing business, especially cross borders, is dominated by issues such as jurisdiction, security, trust. That is the cost of developing, maintaining and securing our relationships. We formalize these relationships based on written contracts, documents, written laws, and these contracts are the basic building blocks of any market economy. The idea behind smart contracts, however, and what you can do with the Bitcoin protocol is that many of these contractual clauses, such as performance, mediation, adjudication, auditing, can be embedded in the hardware and the software that we use, like a vending machine or like a Bitcoin assurance contract. So, and this ultimately delivers great value because it reduces transaction costs. And I'm not talking about the transaction costs that eBay or PayPal takes, which is just 2-3%. That's petty money. Rather, I'm talking about the costs in the contractual phases of search, negotiation, commitment, performance, adjudication, these kinds of things, unexpected costs. Because smart contracts can minimize both malicious and accidental damages. It can lower fraud loss and minimize enforcement costs. At the end of the day, what this means is that it is incredibly scalable because it gives contracts the ability to regulate and automate themselves. So I encourage you guys to go forth, think of these things, and build on top of the Bitcoin protocol. And you can feel free to email me regarding any Bitcoin-related questions at scott@helloblock.io. I'd like to thank you for listening, and now I would like to take any questions you may have. Yes?
Wanted to know a little bit more about HelloBlock. What's the what are the constraints or
Yeah, sure.
what's the stack?
So when I built Tippercoin, Sparecoins, and all these kind of small apps, there were only two options to build Bitcoin apps. You can either host your own node. In the age of cloud services, why would you do that? It's a big pain. Your weekend's gone. You got to sync up with the blockchain. It's 14 gigs. Your node goes down. List goes on. Doesn't give you data the way you want it. Blah blah blah. And the second option is to use Blockchain Info, which a lot of you have probably heard of, and their API. And that's what we did. But that's the reason why we also built HelloBlock, because Blockchain Info is shit. The API sucks. And the most prevalent problem is, well, they don't have a test environment. So how do you see if your code works? What, do you just send small amounts? You can't write automated tests like that. If you've got 500 tests that you want to run, if you want to do integration tests, it's going to cost you, $50 a test. And and not only that, in Bitcoin, it doesn't actually work. You can't actually just send small amounts. You have a large output, let's say 1 BTC, and you spend that. And let's say you want to spend 0.1 BTC, and then a change address is created. But oftentimes what happens is people forget the change address. So they spend 0.1, and then the 0.9 goes to the miners as a fee. And so numerous times people have emailed us saying, hey guys, when's that API going to be done? I just kind of just lost all my Bitcoins testing. So that's the real kind of the idea behind HelloBlock, why I initially started it. But going further, we really want to enable smart contracts because I think that's what's ultimately going to deliver the value in Bitcoin. And one of the most important things right now that isn't implemented that should be implemented is multi-signature transactions. And so PDSH is the kind of the common script that people use. A lot of wallets don't support it. It's kind of hard to set up yourself because you have to have a good understanding of how EDCSA works, and there's just no good interface to do it. Whereas we just want to provide like simple data structures. You can communicate JSON back and forth. We've got a client library that can handle all this for you. So you can just say, I want multi-signature addresses and transactions. Here are my keys. We're an authentication server. Go. And one of the benefits of that is most Bitcoin security hacks happen because a developer keeps their keys in a database online somewhere, and that's targeted, obviously, by attackers because they have so many fucking keys on there. The classic example is Bitcoinica. So they were a leverage trading platform, lost 45,000 Bitcoins. So that's about $20-30 million today. It was run by some 17-year-old kid, right? And what actually happened was, so he hosted on Linode, and some guy just said, hey, Linode support, I own this server, but I accidentally lost my keys. Can you please reset my password? Linode support complies. Okay, sure, here's your password reset, a new access. Boom, all of it's gone because all the private keys are on that server. Now, I'm not saying this is on the negligence of this 17-year-old kid. He's actually a friend of mine. In the same round of Linode hacks, the core developer of Bitcoin, Gavin Andresen, also got hacked. So, I mean, this is kind of a difficult problem by nature. Security is hard, but the best way to do this is split the responsibility. And this is what Gavin Andresen recommended. So if you could have a situation where to unlock funds, you need M-event addresses, public keys. You need 2 out of 3 guys to say, okay, let's go. And I think the best way to handle this is, at least the way we're approaching about this is, you as a developer, a business, you have 2 keys, one that you hold on your server and one completely offline cold. We hold the other key, so we can never spend your money. But every transaction that you propagate goes through us. We give our signature, we apply anomaly detection just to see if there's anything funny going on. Because obviously, if suddenly you make a $10,000 transaction, well, whoa, obviously you're getting hacked. Because normally, it's kind of like $5, $10 here and there, right? And that way, if you get hacked, your database gets compromised, attacker can't do anything. They need either your offline key or our key to do this. So they can't go off on on their own and propagate transactions. They need to propagate through our API server. And if there's anything suspicious, you'll be notified. So that's really the kind of the long-term idea behind HelloBlock. Yes.
Say you came up with a new transaction type or one of these sorts of things you're discussing. How do you get that adopted by the miners? Like, what's the procedures that the miners will take it on board and run with it?
Okay. I guess it's important to distinguish between transaction types and contracts. So, building blocks of the contracts I talked about rely on the transaction types of multi-sig, lock time, and different signature types. These are all kind of standard within the Bitcoin protocol now. There are some more experimental ones that we're not sure whether they'll be adopted. For example, there's the transaction type, or it's actually called a script, or an opcode called OP return, which allows you to embed data, or other ones like like evaluate script. These aren't going to be necessarily adopted by the miners. So, and I'm not sure if you guys are aware, so currently the way it kind of works right now is the core developers push out a release, and the miners kind of almost have like an informal poll to see, and just run the code, pretty much. And if there's a majority of miners running the code, it's adopted. So a lot of the contract types I talked about is actually implementable basically today. Does that kind of answer your question? Did you have a follow-on or?
Developers to agree with what you're doing, and then if they sort of sign off on it, the miners will pick it up.
Yeah, so answers okay, there's a two-part answer for that. And the first answer is you can already do a lot today that the core developers have already accepted. One of their considerations is they want to innovate, but they don't want to bring down the whole network. And actually in the early days, there was a really infamous bug that lets you send Bitcoins from anyone's address. So that was solved, luckily, thank God. But the second part of that is you don't really need anyone's permission to build new cool stuff on top of the blockchain. And it's important to note that new protocols can be established on top of the blockchain. The two examples are Colored Coin and Mastercoin, which use the data embed functionality to create new protocols. Let's say, so Colored Coins works like this. Let's say you are a car manufacturer and you want to say these Bitcoins represent car ownership, and new owners only become new owners if I sign with my private key and release a message that's tied to this particular address that's colored. And this might be like a time-based access key, because I mean, car keys nowadays kind of have a cryptographic handshake anyway. If that's connected to the internet, it could check in the blockchain whether your lease of this car, for example, has expired. And Mastercoin kind of works on a similar concept and establishes potentially the possibility of having like a one-to-one with Bitcoin ownership and gold. So a lot of these transaction types you can already build on top of Bitcoin as a protocol. And I think Bitcoin itself should remain a stable, conservative protocol. Yes.
So the protocol currently works on transferring Bitcoins, and you've raised the concept of using the protocol for share ownership. Do you know if anybody's actually working on using the protocol to actually hold and transmit normal fiat currencies?
There are a couple of altcoins doing something like that that are kind of, I think, they're trying to be like a registry for USDs. It's called USD Coin. Great name, kind of clear. But I don't know to what extent to what kind of success they've had. If you want to do this, I'd love to come to have a chat with you afterwards.
To add something to that, I know that BitShares, not necessarily for just purchasing or holding, say, US dollars, but with BitShares you can actually trade against US dollars. So if you wanted to trade or any other thing that you can get reliable data on. So if you want to trade the prices of US dollars versus Bitcoin, you don't need to actually hold either of those. You can use a prediction market and a sort of transaction matching, and it's a distributed exchange. So you don't have a coordinator organization that you have to trust. So BitShares, yeah, it's pretty early, but it's underway. It's pretty hard to, I found it difficult to understand at first, so